Hello class, we are going to continue our next session on the integration of trigonometric function. Today we are going to solve the trigonometric function which said that integral dx over cosine x square root equals 2x. By seeing this equation somehow seem to be like a challenging one, but by using some simple properties of trigonometric functions will be very easy. You must follow. If you have any question, please write there in the comment. I will reply it after. Let's go there on the step 1, what you call identity. From double angle formula, we begin with a known high leverage identity that student already trust from the fundamental formula. This fundamental relation is already proved by using Simpson formula, where cos 2x is equal to cos square x minus sin square x. This is the double angle identity of cosine. Everything that follows is about reframing, not inventing anything new. We are not creating something new. It is already delivered from the known principle. Then our target here is to eliminate the sign, and we get an expression which involves only cosine. This is where Pythagorean identity become a strategical tool. Very simple and easy. By seeing the fundamental formula from this relation, will you know that sin square x is equal to 1 minus cos square x. Then substitute this relation of sin square x in the expression of cos 2x, which is equal to cos square x minus sin square x. Finally, cos 2x will be equal to 2 cos square x minus 1. Then after getting the relation, we are going to take this relation of the value of cos 2x and we will replace on our given relations of cos 2x. Then we'll remain integral dx over cos x square root 2 cos square x minus 1. Then thank you. Then this step 2 is already even considered to be called substitute. The next session number 3 is a factor. Then remember that if you have the value of cos x, which is equal to square root 2 cos square x minus 1, then try to factorize the value of cos square x in fact, in evidence will remain is 2 minus 1 over cos square x, where 1 over cos square x is equal to sec square x. Finally, we will get cos x times square root 2 minus sec square x. Then replace these relations on the right side in the integrate fraction. You have it above. On the step 4 is simplify. After replacing the expression of cos 2x here, we'll make the integral cos sec square x dx over square root 2 minus sec square x. Then let's take as u is equal to tan x. By differentiating on both sides, this implies that du will be equal to sec square x dx. Then step 6 is integrate. Integrate, this simply means that we will remain integral 1 over 1 minus u squared du, which is equal to sine inverse of u plus c. This relation is derived from the principle which said that integral is the reverse of differentiation. This is the final answers we get. Then after getting this one, remember that we are going to replace the value of u. Remember that we let u is equal to tan x. This implies that the final solution I will be equal to sine inverse tan x plus c. Keep in mind that there is a condition you have to keep in your mind, which said that cos 2x must be greater than 0 and cos x must be different to 0. Thank you very much. This condition it seems to be like a domain of definition of the given integrant function. Thank you, all the best.